Okay, perfect.
Okay, hi everybody. We're going to go ahead and get started today. Welcome to Compass. I am happy to introduce our speaker, who is Dr. Alexander Soloviev. Dr. Soloviev has been a professor at Southeastern University's Oceanographic Center since 1996. He advises students and teaches graduate courses, including physical oceanography, fluid mechanics, and biophysical interactions in the ocean. From September 2024 to September 2025, Soloviev served as an IPA director of the Physical Oceanography Program at the National Science Foundation. Previously, he was an adjunct professor at the University of Miami Rosenstiel School of Marine Atmospheric Science, a visiting scientist at the University of Hawaii and University of Hamburg, and a scientist in the two leading institutions of the former Soviet Academy of Sciences, P.P. Shirshov Institute of Oceanology, and A.M. Obukov Institute of Atmospheric Physics. Soloviev has participated in several major oceanographic and air-sea interaction experiments. He has spent a total of over 3 years at sea. He is the author and co-author of more than 80 peer-reviewed research articles and holds several patents in environmental engineering and oceanography. In collaboration with Professor Roger Lucas at the University of Hawaii, he co-authored a monograph, The Near Surface Layer of the Ocean, Structure, Dynamics, and Applications, published by Springer in 2 editions. So he is a naturalized U.S. citizen. Soloviev graduated from a high school in Zaporizhzhia, Ukraine in 1970. He received his diploma of engineer from Moscow Institute of Physics and Technology in 1976, and later earned his PhD and habilitation, which is a Doctor of Science from MIPT and the former Soviet Academy of Sciences in 1979 and 1992, respectively. In addition to his science degrees, he completed an executive MBA at the University of Florida in 2010 and earned certificate in driving innovation and new ventures in established organizations at Stanford University's Graduate School of Business in 2024. He has been a PI or co-PI on 23 research projects funded by the U.S. federal government, Florida, and private industries. I just read this, I'm sorry. All right, everybody.
Yeah, thank you for the nice introduction. I'm happy again to be here at Rosenstiel School, also at Compass seminar. I'll be talking today afternoon about hidden upwelling on the southeast Florida shelf. Just most of you probably trying to figure out what kind of animal is that. I also didn't hear about this hidden upwellings terminology even 1 year ago. But let's see. First about upwellings, that is pretty much wait, not sure. Yeah, I showed one half of that, but anyway. Yeah, that's about upwellings. I don't need even the slide because it's classics. Upwellings, well known, are wind-driven upwellings, which take place on the eastern boundaries of the ocean. On the western boundary of the ocean, like we are here in Florida, East Florida, we are not supposed to have any upwellings. Rather, when I came to NSU, actually I used to be blue water oceanographer until I get to Florida, and I, for years, was avoiding any coastal areas. As soon as we get to coastal area on research vessel, everything is different, not possible to figure out. But here, eventually I like it, all this complexity, which is especially here in the Straits of Florida. So what, maybe I skipped somehow one slide. Yeah, but still do have some signatures of upwelling, but it's kind of strange. When Dr. Deutsch, our former dean, was the dean, he was inviting coral reef specialists from all United States and world pretty much every month for conciliums, for meetings. And part of these meetings were about upwellings. And nobody had any idea why we do have it. And they were reported by coral reef divers who were studying coral reefs. They were saying it's everything looks on the surface, we go, ooh, it's chilly, maybe 15 centigrade. What is happening? There are no explanation. And were kind of extreme reports like this Riviera Beach, West Palm Beach TV channel in June 2021. It's reported reported fish on the beach, which was by cold water. It lost consciousness and by rescue brought on the beach and dying there. That was something quite extreme during the month of June, which was already summer. There are also unusually cold events like in January 2010, which were covering all reef along the Florida Reef tract, and coral reef suffered extensive coral mortality. I think it's about 50% of corals died at that time. It was also heard from one of the coral researchers recently that similar event was in 2003, but not so well documented in 2011. So question, what is going on? And I get answer, I believe, gradually. Yeah, and this answer came from unusual source. It's AGU EOS letters, and in 2022, one of the associate editors, not researcher really, published this note about hidden upwelling systems, which might be overlooked branches of ocean circulation. How can it be? Upwellings were studied since probably 1920 or something like that, and that was overlooked. Turned out to be its little exaggeration. They were not overlooked, just nobody paid attention to those phenomena, and especially here in coral reef community, nobody knew what is going on, and also I didn't know too. Yeah, what are signatures of hidden upwelling? Hidden upwelling system, also sometimes called non-classical upwelling. By the way, terminology hidden upwelling, it's not really widely accepted because it's a relatively new development, and papers on this subject start showing up, mass of papers pretty much several few years only. And maybe it's possible to call non-classical upwelling, but hidden upwelling kind of sounds for outreach, for example. Yeah, we found hidden upwelling. We need money for continuing research. No, I'm kidding, of course. And this phenomenon refers to oceanic upwelling regime, where cool, nutrient-rich water rises toward the surface, but doesn't not produce the usual visible or thermal signatures that the classical wind-driven upwelling does. Due to the near surface stratification, upwelled water stops at some depths about 20-80 meters and may never reach the surface during summertime. But from our observations in Straits of Florida, later I'll tell that wintertime it does reach, because stratification usually not that intense, especially like today when it's so cold. It's probably a big thing going on. So the hidden upwelling is physically happening, but it is invisible to satellite and sometimes even to boat-based SST measurements. You can go on the boat to our temperature sensor, but you will have no idea what is going on really near the bottom. And I spoke to some coral reef researchers at NOVA, And when I told them, they're a little bit puzzled. Oh, so we cannot see from space, infrared imagery, this upwelling, how come we never thought about that when we're doing statistics, everything? But it's going on, it's happening. Yet it still affects the temperature and nutrient concentration at the benthic boundary layer, that the natural environment is affected, including coral reef community. Probably most of corals already used to, because it's not like one event for 10,000 years. It's happening often, somehow during summertime, for some reason, maybe because it's big contrast, and corals don't like a big contrast in temperature. Yeah, so there have been different interpretations of this, which we may call hidden upwelling. I like the best that from presentation of Lisa Bill and Catherine Gunn, which was on the seminar September 17, 2025. I took this from iTube, so it's a little bit tilted around vertical axis, and that actually was connecting upwelling to AD topography interaction. So this upwelling emerges not on the surface, it emerges inside, and that's it's not always visible from the ocean, from the satellites or visually, because it's coming from below and then it's stopped by stratification. During summertime it's strong, cannot be penetrated through it. Holloway, one of the major contributors to all these AD topography interactions during last almost half a century, he proposed to use something which later was named by him in 2008 as topostrophy. Topostrophy, that's very interesting terminology. Yeah, and I picked up again from presentation of Lisa, and then I started looking, oh my gosh. This is topography, which characterizes interaction, actually intensity of the interactions of eddies with topography. And this criteria, which helps to understand, do we have upwelling or do we have downwelling? Because the sign of topostrophy parameter, if it's negative, means that we have upwelling. If it's positive, we have downwelling. And historically, most of studies were done for positive, like Richter recent publication, 2025, it provides some overview. And the reason that it's applicable not only Gulf Stream, which is western boundary current on the surface, there is another western boundary current, it's about 3 kilometers, which is going opposite direction. And for that everything changes. For Gulf Stream we have negative, for undercurrent below Gulf Stream we have a positive value, and everything determined by the sum of this derivative. It's a change of depth in east direction. If it's if we have the shallow area on the left and deep area on the right, like for Gulf Stream, then this derivative becomes negative. Since it's negative sign, yeah, it's become negative. And that means that tau is negative, and this is conditions which are favorable for development of upwelling. And on the illustrations which was provided by Lisa at her seminar, this schematically showing like upwelling is produced in this interaction area, and it's moving up, and then when it gets to shallow area, it is stopped by stratification. Wintertime may not. Here this is all for Agulhas current, but pretty much no difference. Agulhas or Gulf Stream, just like mirror image from everything. Here is showing direction of the current going out the page, but for Gulf Stream it would be just in page, everything else is the same. And that's pretty much illustrating qualitatively nature of this strange upwelling, which now it's not strange. And why it's not strange? It turned out that it's quite intense. If you looked at the major boundary currents, this is from publication 2022 by Vial. We have this upwelling for all major western boundary currents, and it's compared here to Peruvian upwelling, which on the background of this western boundary upwellings looks not that impressive at all. So this is actually a great machine which is bringing cold water to the surface. This was created from kind of not very high resolution and different data sets, so I would suggest interpreting it qualitatively, not quantitatively, but comparison probably makes sense between classical wind-driven upwelling, Peruvian, it's quite powerful, everyone knows what's happened with Peruvian upwelling when it shut down fisheries for years sometimes. Yeah, so this is happening phenomena, and as previous article in EOS claimed that it was somehow overlooked. It was not overlooked, this phenomena, but people were looking at deep interaction of eddies with deep layers, which that cold water from higher latitudes is propagating towards the equator. And consideration of upwellings, which is near the surface, it just came recently. And yeah, I like that work by Lisa, of course, it's classical work in this direction. It's supposed to be published soon, I guess. Yeah, we'll look forward. Then I may take that picture in normal position.
I can send it to you, Alex.
Yeah, thank you. And what we have on Southeastern Florida shelf. Yeah, I've been involved more than 25 years in research of Florida Straits and shelf. We started, I say 1998 with University of South Florida, Bob Weisberg, Mark Luther, and also University of Miami, Nick Shea. John Van Leer was involved, I remember very well. That was a system probably about 2005, 2010. We were continuously modifying it, developing, depending on what kind of project we have. We have many projects, and for each we needed a little bit different configuration. None of those was devoted to upwellings. So all this came as a kind of random information which we didn't search for, but it just came. And I was puzzled for years. Geez, what is going on here? Couldn't find in any publications. And one of those which was found early was undercurrent jet. In 2006, we had a project, liquid natural gas port, which was supposed to be on the latitude of Pompano and 8 miles offshore. That was supposed to be coming big tankers with liquid gas, evaporating and sending to Fort Lauderdale. We got a project for 4 years to describe physical oceanography and biological conditions. So we had quite good support, and with minimum of pressure, we pretty much were doing whatever we wanted, but still contributing to that project. Unfortunately, that project didn't happen because of 9/11 scares. Folks from Fort Lauderdale Beach, so-called Gold Mile, they protested, saying that it's staying already, looks like not in the US even, not in Florida, probably not in US territorial waters. Terrorists will come, explode this big tanker, and there are going to be no Fort Lauderdale Beach. So eventually it was closed, but they were continuing supporting us. in after that. So what we found, that was again byproduct. Main product was deployment of ADCP mooring at that was 250 meters, looking up ADCP and looking for currents. But when we hired Walton Smith, this research vessel, University of Miami, also ANOLS, NSF funded, I looked at the technical description. Oh my God, they have so perfect equipment, oceanographic equipment. Let's do something else. And I convinced the captain not go directly to that 8-mile offshore location, but go along the coast and then do transect. Each time we were doing on average every 2 months this experiment. We were doing transect from coastal area, Pompano Beach, to that location, cross shelf location. First, I don't know for what, but then when we start looking at first images, we were quite impressed. On the left side, it's contour plot of current speed. This looks okay. It's a signature of Gulf Stream, and this is bottom waters, and this is velocity. But when we look at current direction, so instead of analyzing components, we looked at direction, and we see this strange creature. This looks like this reddish colors. It's direction up north, as Gulf Stream is normally going, and this is just back 100 degrees back. It's counter undercurrent. We thought it's some kind of who knows, and that was April 5th. And then we went May 1st, next experiment. You still see it, but not the same. Looks like it was kind of varying in shape, but still there all these months. Later, when we started using gliders, we found that it's varying pretty much frequently on a time of hours, maybe, all these fishes, because strong current, and this is undercurrent, all this is going back and forth. These were just snapshots, one-time snapshots. What's interesting, when we get to November 18, it's almost winter already. It's almost disappeared, but not completely. It's get on the surface. So it was, but it was already on the surface. And the explanation is that stratification is not strong, so it was able to just get through stratification and become countercurrent. Before it was undercurrent, winter time it became countercurrent. Yeah, for a few years we were trying to digest all this data and decided finally to publish it, and published in 2017 in Deep Sea Research. And this is a schematic representation how we interpreted our observation. So this is for Florida, and this is bottom topography in the Straits of Florida. We have this main current, Florida current, and about 10% of that intensity southward flow. Just 10%. Sometimes it's big, but it's kind of fluctuating. That was interesting. There is not only current is bringing everything, including biology, DNA, up north, but some can return back through this little channel, and that gave answer to some DNA specialists who were seeing propagation of DNA not in one direction, but in opposite direction too. More recently, we got Wirewalker, we got gliders, G3 Slocum G3 gliders. They have a propeller thruster, so they can operate in Gulf Stream. Other types of gliders, they have no chance because they will be taken by Gulf Stream. This also have a problem, but we still can operate. So we were then using this combination in order to look. Yeah, we actually, did we want to look at Upwelling? We probably wanted to look what's going on one of the projects. So this was equipped with CTD and with ADCP going up and down every like 10-15 minutes. And the glider had ADCP, LADCP, in order to be able to follow, to do measurements from moving platform. And we had CTD, of course, and also 3 optical channels. Now we have oxygen, 2 channel. And we have 2. Let me try, see, maybe I can produce that video. Yeah, there was sound, but sound I have to turn off because it was resonating. Yeah, so that's typical deployment, which we do on average every 2 weeks for almost 1 year. And it's going by sliding trajectory down. When it approaches about 50 meters before hitting the bottom, it was turning and going to up trajectory. When it was surfacing, it was possible to change its trajectory if we needed. This is quite smart instrument, but sometimes it was doing mistakes. So we see, oh, it's going not where we wanted, and correct it, and it get for another mission. Several cycles it could be doing without surfacing. Then it was surfaces, so satellite transmit position and ask, are you happy? What we see? And we were correcting or saying go. We were testing different types of trajectories, and finally ended up with 2. One is, we call it a snake-like trajectory. What's its advantage? Because we can cover big spatial space. It's 3-dimensional. So just a glider starts here, and it's cycling, turning, and we're going typically to Jupiter or something like that. After getting to Jupiter, we couldn't control any more glider. Reason, shelf becomes shallow, and for this instrument, in order to make turn, it cannot do it on the surface. The surface is just drifting and waiting for connection to the satellite. It has to go down, but if it's only 50 meters, it has no space to. And that was usually emergency, because we were trying to find a way how to get it back, because it was quickly going away from shelf, from coast, and that emergency services which are available for private yachts, when it's more than 10 miles, that time they were saying, yeah, we cannot have any iPhone connection, so we cannot coordinate with them. When it surfaces, transmit coordinates, that's it. And hiring big ship, yeah, that's order of magnitude bigger money to go search it. So we are trying first sink below Gulf Stream, because not so strong currents there, and go back. Sometimes it was working, but one time we sink and never seen this glider again. What happened? We have some hypotheses, but anyway, it disappeared. Fortunately, Nova Southeastern University, it insures all equipment, and we were reimbursed by, it was probably 250,000 by one of the insurers, and we bought new, even with even upgraded sensors. So that was, I don't know. Yeah, that was no expert limit technology. We intentionally remove any of this program, which can be problem if you get lost something expert control. Yeah. Anyway, we continued measurements and just didn't allow glider to go too much after Jupiter. Just stopping and taking it using that emergency service for private yachts. Another type of trajectory was loop type trajectory. Again, this happened accidentally. One of our pilots around 3 a.m. get asleep and lost control. This glider surfaced, stayed for a while without any commands. It decided to return back to original place. This is a location of Wirewalker, which at the beginning we always were comparing what Wirewalker doing in ADCP, what is glider, and because of current, he did a loop. Yeah, instead of punishing this person, we actually have to him thank you, because what happened, we found an interesting feature. So when we look at in detail in this trajectory, and these vectors, this is a standard product of glider, which is in the software, it's 20-meter speed, current speed. That contour plots, that's our own program. We had to write it with bottom topography, but this is standard. And 20-meter depth. So what we see here, and it's even in bigger scale here, that this vector starts rotating. And it's rotating counterclockwise. So that's cyclonic eddy here, what we got. Wow. And then we start thinking how this cyclonic eddy may be connected to undercurrent jet, which we are observing. Yeah, Dr. Deutsch, somehow before even any gliders, he said somehow that's probably eddy production, this undercurrent jet produced by eddies, submesoscale eddies. We had no evidence, nothing. But when we got this, oh, Dick, you're absolutely right about that. So we have submesoscale eddies. And then one interesting question. When this eddy formed and detached, it has orbital circulation velocity probably about 1/2 of Gulfstream, because one side is formed on the Gulfstream side, another, let's say, it's 0. When it's detached, it may have 1/2 orbital velocity, which is also available on the coastline side. And that pushes water south. And when it pushes south, it enhances that current, undercurrent. Then was question, what is primary here? Is it primary current, which due to shear with the Gulf Stream produces this eddies, submesoscale eddy, definitely by the scale, or eddies produce this current? And after some discussions, we get to conclusion that it's problem of chicken and eggs. You never say what is primary. They are kind of coupled system, which is excited probably by itself, because it's exciting with submesoscale eddies, and eddies help to produce a more intense countercurrent. So that's at this point some idea about this phenomena. Of course, future research may say that it's wrong, or maybe it's right, but it looks like that is coupled self-exciting system. Probably should be some simple equation of generation, like in radio electronics, generation of waves, radio waves. Of course, submesoscale eddies on Southeast Florida shelf is well observed and studied, described feature. That is Nick Shea publication 2002, in which at NOVA we also participated. That was a generation of submesoscale eddy within 3 days life cycle. And we see here first it was relatively smooth currents, and then started some distortion, and here it turned into closed eddy. And you can see here that velocity here probably not very small. It's probably some percentage, maybe 1/2 of Gulf Stream. So it produces really some kind of push southern direction. And then it's all relaxed and it was gone within 3 days. There are several, of course, publications, and Brian House, of course, contributed much in all the studies, lots of publication. I just looked at the first, which was done in collaboration with the University of Florida, University of Miami, and NOVA Southeastern University around year 2000. It's 2000 probably. Yeah, 2000. We did have a ADCP there at 11 meter isobat, and probably at 20 meter and 50 meters, but I never had chance to look. That's so much information to digest. So maybe that hypothesis is working, and it's a coupled system. Yeah. And what is time? No. That's it. Yeah, it's only 7 minutes left. This is a resulting graph from 1 year of experiments with glider. Probably about 20 or 30, maybe more deployments. So we have on this graph horizontal axis this northward velocity, which is measured by glider. And on vertical axis, east velocity, also in meter per second. There are many measurements, so we have reasonably good, in some places here, 95% confidence intervals. And what's happening here, as soon as northward velocity turns opposite way, so we are in that jet, we see that it produces water motion in eastern direction, which is upwelling type motion. But it's happening not immediately, it should be some kind of critical jet speed, maybe about 5-8 centimeters per second. Before that it doesn't produce anything. So is it evidence also that upwelling may be related not only to eddies, but it's also floor circulation produced by those eddies. So that's lots of now material to think about, necessary to go further and to understand what is going on. And this is, I believe, a practical. There is.
Alex, can you tell us more about what the dots are? How you get this single velocity out of every element?
That was already done over 3 years ago by master's degree student who is now PhD student and in Harbor branch. My understanding, as I remember, it was taken integrated average velocity from 20 meters down to the bottom, my understanding. Depending on where was a glider, it could be deeper, could be shallow, all is mixed here. And the vertical axis, and we are looking at both components, what is northward and other southward. So as soon as we get a southward component, somehow it's bigger fluctuations here, maybe because it's less statistics. Yeah, we see that the flow starts moving towards eastern direction, which is away. So water is moving, yeah. So what we have after all these glider experiments, then what kind of this hidden upwelling can do for environment on the shelf. I go again back to that extreme event that happened on Riviera Beach and reported by West Palm Beach TV channel on 26th of June 2021. So we have this, we do see this dead fish on the beach, and 3 years after, not exactly same day, same date, but still in June, we looked at results of our measurements with glider not far away from that location where this was found. What we see here on the left side, this is contour plot of northward velocity. This was about, I believe, 150 maybe meter depth, and color coding. So this is moving northward and this moving southward, and this is again expressed in the form of direction, but instead of green we use blue here. So this is a movement towards north, and this is movement opposite direction. So we see clearly here undercurrent, and this is northward component. And then we look at the temperature, and temperature is increasing from minus 15 to whatever was 28. Since this is close to the bottom already. So this cold water was moving up on the shelf, and it was reaching more shallow water where it was affecting this fish. And temperature difference was quite significant, almost 15 centigrade, and fish got unconsciousness and washed by waves on the beach. So that seems to be consistent explanation is that hidden upwelling. Yeah. And what is reef system on the Florida shelf? Southeast Florida shelf. There are Florida reefs going from Keys up north, and they start north from West Palm Beach, from Palm Beaches in the Martin County. And from the previous example, you can see that it's quite a strong upwelling taking place there. And upwelling probably increases because if we look at that parameter which was proposed by Holloway, we see that it's proportional to Coriolis parameter, and Coriolis parameter increasing. So we're going up north, we're increasing probability of this topostrophe phenomena, which in this case it's bringing upwelling and bringing cold water. And that upwellings, hidden upwellings, might be the reason why corals don't go up like to Washington DC or somewhere, because they're all time stopped by cold water. When I googled and asked actually why coral reef system doesn't propagate beyond North Palm Beaches, and question was because it's some kind of cold water events. Some layer of cold water are coming, not saying that it's upwelling or anything, but that's probably most probable reason is upwelling. So let's stop upwelling and corals will go to Washington DC area and get more money for research. Yeah, and that's pretty much all, and let me formulate conclusions. Yeah, the classical wind-driven coastal upwelling is predominantly observed along the eastern ocean boundaries, such as the California shelf. It's not observed, theoretically, it's not observed on the western boundaries of the ocean. However, an alternative and powerful but less studied form of coastal upwelling exists along western boundaries, which is driven by eddy topography interaction, topostrophe. This upwelling does not generally penetrate the strong near-surface stratification of summertime coastal ocean, but can substantially modify temperature and nutrient concentrations within the benthic boundary layer. In recent literature, this phenomenon has been termed hidden upwelling. Is it good or not? Will it stay or not? I don't know. But at this point, sounds like good terminology for the time being. Analysis of coastal oceans ship and mooring-based ADCP observations, supplemented by recent measurements from a Wirewalker and a Slocum G3 glider, equipped with an LADCP technology, suggests that the dominant mechanism driving hidden upwelling along the South Florida shelf is the eddy topography interaction. Because coral reef benthic communities are highly sensitive to changes in temperature and nutrient supply associated with coastal upwelling, this work provides new insight into subsurface physical drivers of reef variability and has direct relevance to coral reef management on the Southeast Florida shelf. And some acknowledgements. Yeah, I acknowledge my colleagues, my former dean, Dr. Dodge, first, who helped to keep this project alive for more than 25 years. We also had physical oceanography lab staff. Yeah. And several people, including John Wood from Ocean Data Technology from Cape Cod, provided logistical and field support to the project, and also Slocum Teledyne was very helpful, helping us to figure out how to operate these gliders in very strong current conditions. This research actually only time when I had to focus on this specific issue was when I was at NSF, and they have 20% release time when it's possible to do research. So that was dedicated time. Unfortunately, I was mostly involved in all that bureaucracy, but anyway, I was able to look with fresh mind on this problem and create this presentation. Also, Julian McCreary, who was dean a long time ago, he helped to establish that, and I contacted with him recently, and he did some critical comments. He was studying Upwelling 30 years ago, probably. Really well. Yeah, thank you very much for inviting to this seminar.
Right. Thank you. Do we have any questions?
Yeah, John?
Thank you very much. Tom Lee, who worked here for many years, studied what he called spin-off eddies along the western side of the Gulf Stream, and part of that included upwelling.
Wow.
So you might look at some of the ancient literature.
Yeah, that's fantastic. Yeah, I look at literature, I could not find much.
Yeah.
But of course, if it's not a targeted object, targeted research, I'll of course look at Tom Lee. He retired probably a long time ago already.
Yeah. Yeah. The areas further north, the coastal, the continental shelf gets much shallower, so it also tends to be colder. There's a scallop fishery and things once you get north a little bit beyond the Palm Beaches, and there's also similar things going on in the west, in the Georgia Bight, and evidence of cold water up there too, which is another thing you might look at. Thank you.
Well, thank you, Jim. Yeah, of course, that's we go up north and more this cold water is coming, and maybe that's related to formulation of topography, which is proportional to Coriolis parameter, as originally was proposed by Holloway, but later they replaced sign of Coriolis parameter or sign of latitude, but that's probably makes not much sense. The only reason I think they do it sign because Coriolis parameter is very small, and then they get so small topography values not convenient to operate with them, like 10 to minus 4, 10 to minus 5 maybe. But that's one of the explanation why it's more upwelling, supposedly for this type, hidden upwellings when we go up north. And my understanding is that eventually these upwellings kill coral reef and further propagation up north. Maybe historically it was more up north, I don't know, honestly. I'll ask Dick Dodge. He should know. And that something happened, maybe warming.
Roland, do we have any questions online?
Yes, Arthur, do you have a question?
Sure. Nice talks, Alex. You mentioned the harm of this upwelling to the coral reefs.
Oh, yeah.
In this time of warming seas, could this upwelling maybe help explain some of the patchy distribution where some coral is showing some strong damage and some coral is a lot healthier?
Yeah, it may of course affect statistics because this topography, it depends also on shape of bottom topography. It may enhance in some places because one component there involved is change of topography in eastern direction, another is northern direction, because that now it's described in the literature. Maybe that some features about bottom topography, variability, they can change intensity of the hidden upwelling, and they different way affect coral reef survival in a warming climate. And also, I think I should mention a paper by Dr. Riegel, who at some point, probably 2002, published paper saying that these upwellings can save corals from overheating when it is global warming effects. So that's a dual effect. But when temperature going is too low, like 15, 16 centigrade, they start dying. Not all together, but first one more vulnerable creatures and then less vulnerable. So they don't like it. Fortunately, these upwellings don't last long except like 2010, upwelling was a few weeks, and about 50% of corals died from that.
Thanks, Alex. Interesting talk. After looking at a lot of the radar maps, because I was involved in that a lot in the 90s, late 90s, I always observed that the most dramatic submesoscale eddy generation in the U.S. The edge of the Gulf Stream was after strong northeast winds for a while. And I'm wondering now, I almost viewed it watching the radar maps, it almost looked like it was like everything was kind of backed up and then all of a sudden let go. But which is kind of weird when you think just about a surface forcing, right? But then now I'm wondering about what the role that the undercurrent enhanced by northeast winds might play in that.
Mm-hmm. Yeah, definitely a classical upwelling is observed here, especially during extreme events. We did situations during Wilma, and then 2005, and then in 2017, I forgot the name of that storm, when like during Wilma we got upwelling 5 centigrade, because it was strong impact of wind stress increasing quadratic to wind speed, and that becomes huge, and wind stress start playing a role in that circulation, subtropical gyre, because normally in western boundary current wind stress out of picture, because it's a balance between the movement of water up north and getting positive, getting negative vorticity, relative vorticity, and also frictional forces generating eddies. And wind doesn't do much. On eastern, wind is involved, and that's why you have upwelling. But if you have hurricane, that's become just enormous wind stress and upwelling. And might be also the strong winds, northeast winds, they are affecting, producing combination of hidden upwelling and real surface upwelling. Maybe this is to look. Maybe we have even data to look. Just time.
Yeah, I would agree with that. I think because you were using radar. Is this still?
Oh, yeah, radar of course great tool here.
Surface, you're seeing the surface. Yeah. So like Alex said, you're only seeing the events that reach the surface, and that's typically with a wind event in combination. We saw the same thing in the ecological.
Yeah, of course, that's good point. It's
So
mixing
these-
and it's good. Sure.
So the submesoscale instabilities, they travel along the front of and they travel along the front of all western boundary currents. And in fact, they get larger as you go north in the Florida current. So that may be also a reason why you get more upwelling, because the more the eddies grow, the more you get the secondary circulation.
Oh yeah. That necessary to consider, I believe, as coupled system always.
Do we have any other questions in the room or online? No? All right. Well, in that case, let's give Dr. Soloviev another round.